right, folks, if you don't know me, I'm annoying. Actually, I'm Glenn Renfro. I work at Pivotal. I'm one of the Spring End engineers. I work on Spring Cloud Tasks, Spring Cloud Data Flow, Spring Cloud Scheduler, Spring Batch, and wherever else they need me. And I'm also, like Roy, a member of DevNexus board as well as the Ajug board, along with Burke and Laura, and there's others coming. So, Roy?
My name is Roy Clarkson. I'm a principal engineer at Spring at Pivotal, and I also manage the Spring Cloud Services team. And I work on the tiles that we deploy, or we build the tiles that are deployed to PCF. So that's going to be my portion of this talk.
Sweet, the cool part.
Yep. Right. Cool.
All right. First off, anytime we talk about scheduling, the first thing I want to do is I wanted to get the sheer excitement out of your system, because I know when I say scheduling, people think and look something like this. I have given this presentation before, and I've taken pictures of the audience during it, and you can see the sheer excitement in which they've had during this presentation. But in all honesty, while it does seem like boring, it seems like something that you really doesn't seem exciting, it's actually something we all do. And at some time in our career or even in our company, we all have apps that are scheduled. So what does scheduling look like in the cloud? So what we're going to do is we're going to get some terms down. We're going to talk about what scheduling means. We're going to then talk about ways in which you can schedule. Then we're going to be talking about how there are various implementations of scheduling and how they're done in the cloud. Then we're going to talk about how Spring Cloud Task is your first introduction into how we can simplify our apps that are running in the cloud, how they can be good citizens inside the cloud once they are deployed out there. And then finally, Roy's going to come in and show us how we can simplify it even more so than what is available and what I'm going to show you. So vocabulary, which everybody is so excited about. Okay, this is getting nice. Okay.
We picked the most exciting talk to follow up DevNexus.
Yes. That's the reason we gave you pizza, so you would show up. So what is a task? So a lot of times we think about microservices as what? Microservices we think about as those things that you bring up, they run, and they stay up for a long period of time until something brings it down. It's what we call an LRP, a long-running process. The only times that they're brought down is if an external agent actually brings that application down. That could be repaving. That could be actually going in and killing the app at that moment. It could be an upgrade, anything like that, but it's an external agent actually bringing it down. A task is different. It's ephemeral. It has a start and then actually has an ending point, meaning it's expected to stop. And so we could think of things like maybe a billing run. So an app that starts, does its billing processing, and then terminates it. It has a fixed life cycle. Just because it has this ending and it has this kind of ephemeral point of view, it still has to follow the same 12-factor apps as a long-running process. So as we go through this, you may see me talking about tasks. You'll hear me refer to sometimes as tasks as jobs, but that's just because between the two platforms that we're going to be discussing, they use two different terminology, but we're going to bridge that. So again, tasks can also be referred to as jobs, and the tasks are microservices, and they also have, again, that termination point.
Can anybody name a factor?
Oh, you just had to do it. Huh? Yeah.
I was going to give away a book, but you brought the books.
Yeah. Well, how about configuration? Huh?
Yep.
Go get you a book. See, we're going to start throwing out vests out here. All right, so I bet you didn't have a presentation like this at DevNexus. Ha ha ha. All right, so what does scheduling mean? It means, first off, we are going to be launching the task, right? We also, once the scheduler does, it launches a task, we have to also know, did the task launch? What's its condition? How is it behaving? We also need to know, what's the final status of that task? Did it terminate successfully? Did it terminate unsuccessfully? What information did it give us upon its termination? These are things that make an application a good ephemeral microservice. And then lastly, how can we manage that failure condition? One common failure condition would be is if I'm doing like a bill run. Again, I'm going to be using this example a little bit, and I'll even throw in a manufacturing example in a little bit. But about if it's a 6-hour run and about 3 hours in, it fails. Okay, oops, it's because we ran out of database space. Not supposed to happen, but it does. We go in, we repartition the database, increase the size of the database, we kick it off. Do we want it to run the first half of that again? No, we'd rather pick up where it left off. So this is something we need to think about if we're running ephemeral apps out in the cloud. So we've talked about so far, what is a task? We've talked about what it takes to be a good citizen if you're tasked to be a good citizen in the cloud. But now we want to talk about how can I schedule this task? We have the tried and true. We have the calendar, right? So, I want you to start up on December 31st at exactly 9 p.m. I want you to, kick off every day at 2 o'clock. It's classic scheduling. But there's also event-based scheduling. A classic event-based scheduling could be that we are actually listening to, an example would be if I'm running and I'm monitoring social media, let's say in particular, there's a major sporting event, like the major sporting event that occurred in Atlanta that may have moved us to the Cobb Galleria because they felt it was more important than DevNexus. It was called
the Amazing Bowl?
The Amazing Bowl, that's right. We can't use the real word. The big game. So during this event, they're capturing and everybody's monitoring tweets and monitoring Facebook, even though it's now unpopular, unfortunately. But during the Twitter, if they're monitoring all the tweets, they may be looking for maybe a hashtag of maybe they ran an ad. For example, Papa John's ran an ad, and as they run in that ad, they're looking for their hashtag. Maybe they are actually monitoring Twitter using what's called Firehose. I can actually go into and pay Twitter and get all the tweets that are coming across. I can then take those tweets, filter them out, and look for that specific type of hashtag. And maybe after a certain point, maybe we've reached 10,000 or 10 million hashtags of, /hashtag Papa John's. By the way, I'm not getting paid to say that. I want to then launch a batch job that will then begin an email campaign and send out emails to all the people that have tweeted out that hashtag and say, hey, if you order now, we'll give you, 30% off. Okay, so at this point, what we're saying is that I can have a stream of data flowing in, and that stream of data can then have an agent actually kick off a ephemeral task to do that work, and then again, once that task has gone in and done all the emails, terminate. Okay, we don't want it to sit there running all, as a long-running process, waiting to receive it. That just takes up resources. I'd rather have that ephemeral app out there just running when it needs to run and terminate when it's finished. So when we talk about that, we were talking about where can we do the scheduling, right? We can schedule in, of course, on our own hardware, but we also, if we have a cloud implementation like Cloud Foundry, we can use what's called PCF Scheduler and utilize that to do scheduling there. Or if you're using Kubernetes, it's called cron jobs, okay? Despite being on two different platforms, they have a lot in common. Unfortunately, I have a cat named Suspicious Cat, and he suspects I'm not telling you the truth. So I'm going to go in and prove to Suspicious Cat that these things have a lot in common. Actually, my cats are orange and the other one's black, but that's okay. I like Suspicious Cat. He's a good cat. Both Cloud Foundry and Kubernetes both have the concept of ephemeral apps, meaning that in Kubernetes, they call them jobs, and on Cloud Foundry, they call them tasks. The reason this is important is because if you look at both providers here, they have a native long-running process in which concept which says, hey, if Kubernetes, if my pod comes down, what do I want it to do? Bring it back up. Right? Cloud Foundry, I have an app that's running. What happens if that app goes down on a long-running process? What do I want Cloud Foundry to do? Somebody? Bring it back up. I don't have enough books, but thank you. So in this case, but yeah, I wanted to bring it back up. what happens if the task fails? What do I want the system to do? Or not fails, it terminates. What do I want that application, this cloud provider to do? Do I want it to bring it back up if it terminates? No. Why? It's done. Stop. Yay! We saved money. Woohoo! So right now, Suspicious Cat is looking a little in trouble now. They both have to have, if I schedule something, it has to have a schedule name. I have to have an application associated with that schedule. And with that schedule, I want to be able to associate either command line args to be able to tell my app what to do, or I can set properties to say, hey, based on this given schedule, when you launch, I want you to use these command lines in these properties. Both of them have this concept that I can, when at scheduling time, be able to set those. More importantly, how do you schedule? My gosh, it's full of cron. Both of them have a cron implementation.
This is the most exciting part of the presentation.
Yes, don't you see it? Everybody knows cron. But both of them, that's what they use in order to do the scheduling. Now, sometimes I've had some people ask me, okay, what if you have specific needs? Like, cron is great, but it's kind of dumb. What if I want to be able to launch it, every day, every Wednesday of every month, every Wednesday of every week of every month, except for if it's a holiday, right? You have those exceptions. If you want to afterward kind of talk to you about that, there are ways in which you can handle that using these implementations and using data flow. But I didn't want to kind of go through those, but there is ways in which we can do that. But if you're using just a stock scheduling, this is what you have to use for just classic scheduling. They both offer a RESTful API. So how many of you have actually, let me put it this way, how many have Kubernetes and using Kubernetes in production? Wow, that's numbers growing. Cloud Foundry? There we go. Okay, so equal number. There we go. They both have a CLI. So you can say kubectl or just CF. Both of them have that ability. Unfortunately, I got caught in a lie. Suspicious Cat was right. PCF Scheduler on Cloud Foundry has a wonderful UI in which you can do scheduling. Kubernetes does not. So, unfortunately, or fortunately, Suspicious Cat wins the argument. So, what we've covered so far is we've covered the vocabulary. We've covered what tasks are. We've covered ways in which you can actually launch tasks via scheduling or via event. Now, what does it look like? So if I'm on Cloud Foundry, what does it look like? Well, the first thing I have to do is I have to push the app to Cloud Foundry. So if I have a Java app, I want to push it out there. Then I want to bind the services that the application is going to need. And then what I want to do is create that schedule. In this case, unfortunately, they also call that scheduling process called a job. Don't get confused. It's a task. And then you create your schedule for that task. What does that look like? So from the Cloud Foundry API CLI, you're going to do a CF push, your app, and then you specify the jar you're going to use. Then from that point, you're going to bind whatever services. In this case, I have a service called My Database. And then I want to create the job, CF job test app, and then I give it what? The name. And then lastly, I want to give a schedule to that job and where I put in my cron expression. Okay, it's 4 easy steps, and if the app is already out there, all you have to do is the last 3. Kubernetes is going to look very similar, just a little different. Same premise. If your Docker's image is not already out there, you need to make sure your Docker image is pushed up to your repository. If you are using spec files, you need to set up a schedule spec and a job template spec. Or if you're using kubectl, who says kubectl and kubectl? I say them both, so you'll hear me say kubectl and kubectl. This is basically the command line for Kubernetes. You use kubectl run, and you can create the schedule. What does that look like? If you are using a YAML file, I wish I was about to start pointing here, but it doesn't really work that well, does it? I'll have to point here. You're going to set up your schedule spec. Again, that's just going to be your cron expression. Then you set up your job template spec. And then from that, you're going to specify the image that you're using. You can see here I have Spring Cloud Scheduler SPI test app. And then I can pass in whatever arguments I want, which in this case, I'm passing in a name called hello. And I have what's called the restart policy on failure. We'll talk about that in just a second. And basically, you do a cube create -f your cronjob.yaml, and you have just taken your app and set up a schedule for it. Okay? If you're using kubectl, it looks very similar, right? Cube run my schedule, the name, or should I say the name of your schedule. You specify your cron expression. Again, your restart policy, and then you set up the image that you want. So the restart policy, I want to talk about that for just a second. So you notice that I had in both examples, you see here I had a restart policy of on failure. The next one I had a restart policy of never. That's important because when we were talked about before, if a task ends and it ends successfully on Kubernetes, it says, okay, we're done, don't do it again. Unless it returns a non-zero result. By default, Kubernetes is going to look at that and it's going to say, if I have the default, which is, which is on failure, it's going to retry that app over and over and over infinity until it gets a 0. That's usually not desired behavior, unless you built it into your app that it can be restartable and keep going until it successfully completes. What I recommend is you have a restart policy of never. That means if it fails, it terminates. That's when we're going to start talking a little bit about how Spring Cloud Task can notify you and let you know, hey, there's some action required for this given app. So, yep.
Those things seem really easy to do.
They are.
I mean,
yeah. I mean,
so, write some YAML.
That was emotional, man. Okay, who likes writing YAML in here? I better not see a hand. Oh, you!
So you're telling us there's a better way to handle it?
I don't know. Is there? Do you think there might be?
The presentation's over if we don't have a better way to show it.
Okay. We'll hurry up. We'll get to the good stuff. Okay. So out of our list, we've actually only covered the runner. We've only taught you how to launch the task. Now we're going to be digging into how can we track the app, obtain its final state, and then manage the failure conditions. So Spring Cloud Task is an app that's out, or it's a project available on GitHub, available by Spring. And basically what it does is, if you have a regular boot app, does boot apps work in a Docker image? Yes. Do they work as just straight CF pushes out to my Cloud Foundry instance? Yes, they do. Will they work as an ephemeral app? Yes, they do. They do perfectly. But to be that good citizen out there, what did we say that we wanted to be able to do? Record the fact that the application ran and succeeded without having to, and be able to go to one place where I can know what the status is. Because how many of us actually just use default namespace in Kubernetes in a single cluster for all our apps? I don't see hands going up. That's correct. You don't. You put it in, I may be deploying to multiple clusters out there. Same way with Cloud Foundry. I may have multiple instances where I'm deploying my app out there. So I need a common place where I can capture this information and know that my app actually started and be able to know, did it succeed? If it didn't succeed, what was the error message on it? Or if it did succeed, what information does it have for me after the success that may help me or determine whether I should launch downstream applications? Task also has other features into it that you can just set properties that say, look, if this app is already running, I don't care what cluster it's running in, if it's Kubernetes or what instance it is running on Cloud Foundry, don't start it again until it's complete. Meaning if the cases where I may say this app takes an hour to run, for example, and maybe the last run started 15 minutes late. Okay, at the top of the hour when the next one's supposed to kick off, it's going to see, again, by just setting a property, Spring Cloud Task will, the boot app will start, but Spring Cloud Task will go in and say, hey, that app, I'm already running, stop. Give them a good, clean message saying that I stopped because I'm already running, and then terminate softly. So these are things that Spring Cloud Task do for you so that you have, again, your application can be a good citizen in the cloud. Secondly, we had the other issue is how do we manage the conditions where it fails halfway? How many of you coded Spring Batch in the past? See, okay. Don't be ashamed. It's a good thing. I've coded Spring Batch too. All right?
You wrote Spring Batch.
Parts. That was David Sire, Michael Manella, and
Glenn.
Mahmoud Bassine. Those are the people you want to blame. I just get pulled in once in a while to do little bits of it. So in that case, the important part of a Spring Batch is the following. Not only does it give you a framework in which you can actually simplifies your ability to write batch type apps where I may be going in reading from some kind of source, file, database, stream, filter, enrich that data, process that data, transform that data, and then write it out to a final destination where, again, whether it's another database, another stream, or another file. It has these features that allows you to do this so simply with the ability to have retries, all this good stuff built in that you normally have to write on your own. But also importantly, it has the ability through you be able to set a context so that if the app dies halfway through, you can set it up so that when it's kicked back off, it'll pick up where it left off at versus you having to get the app having to start back from all the way to the beginning and reprocess all that data. So with Spring Cloud Task and Spring Batch, you can fill out those last 3 checkboxes.
So is Spring Cloud Task built on Spring Batch? Pretend I'm ignorant. Tell me.
Well, no, it's actually built.
You don't have to pretend very much.
Spring Batch or Spring Cloud Task does not. Does my app have to be Spring Batch? No. Does it have to be a Spring Boot app? Yes. So let's see what that looks like. So what I'm going to do is I'm going to go here. I'm going to do a new project. Yes, Glenn, I can do a project. And then I'm going to click Next. I'm going to use Spring Initializer. I'm going to say io.spring. And we'll call this Ajug Fun. I have to be careful now. It used to be fun meant fun, but now it means function. And I've been working with functions now, and I'm sitting there going, oh my gosh, should I say function or fun? So, well, fun means, woohoo, it's fun. Boy, y'all are really, really excited about this, aren't you? So in this case, we're going to go to Cloud Core, and we're going to say we want Cloud Task. I'm going to go to SQL, and I want to include JDBC dependencies. I want to have H2 for my testing, and I'm going to be using MySQL as the database I want to store my state of my tasks in. And let's go ahead and click Finish. Do I want a new window? Why, yes, I do. I tell you what, these apps are so polite. By the way, there was a race to see if I could out-talk Josh Long. I lost. It was close. No, it wasn't. So in this case, we're just going to have a Spring Boot app here. I'm going to enable auto imports. And we're going to create a bean here. And this is just going to be a command line runner. This is something you can do. This is not task specific. This is just Spring Boot app. Oh, yes, absolutely. Thank you for asking. You rock. Go get a book. Come on! I can't guarantee them after this. Or you can, well, there's the red ones are pamphlets. You got, just pick one. You win. All right, so in this case, what we're going to do is do system.out.println. And we're going to just say hello world. Okay. And it's going to do this impressive thing that Spring Boot was written for. It runs an app. Oops, sorry, it won't run anything because, yeah, okay. Well, if y'all said that, somebody could have said, hey, you forgot one. I would say, get a book. And see, by the time it's all done, he won't have any books to give away. So in this case, we'll zoom in here and we'll see that, of course, it did nothing more than hello world. Yay. Well, let's take a look at it and let's turn this and change this into a task. All right, y'all ready? This is going to take a lot of coding. Ready? Okay, we're done. So what does this do differently? Let's take a look here, and let's go back out to my database, and we're going to run and take a look at something called a task execution table. Nothing exciting here because nothing happened yet. So in this case, we're going to go back to Spring, to my Ajug Fun. We've added the enable task. Now what I want to do is you're going to find out my secret password for my local MySQL instance. It's password. Do not tell anybody. We're going to do edit configurations. And we're just going to tell all I'm doing is just telling my boot app where it can find the database. Nothing more. Paste. Okay. Okay. Hit run. Same thing, but what's interesting now is if I go back to my database here, rerun, we see that the app actually recorded the time it started, this time it ended. You can set the application name if you want to. We see that it's ended successfully. There was no exit or error messages. And if it was in a cloud, we'd have an external execution ID because this is the ID in which we are given from the operating system or from the cloud platform when it runs. So all this information is captured by Spring Cloud Task, but since I'm locally, it didn't record it because there was not one there. But what's more important, what happens if, in this case, I throw an illegal state exception? No task for you. Rerun the same thing. I'll zoom in here. And we get the nasty stack trace. But what's important, more so, and I keep going to that, I should go here. We see now that we ran again, but we see that we have an exit code of 1, but also now know why it failed. And no matter what cluster I'm on, no matter where my app is running, I have one common place to go in and check the condition of my task executions. So through Spring Cloud Task, I can now take my app and put it on any network, or it doesn't have to know anything about what cloud it's put on. It's just going to behave in this way and give me all these features by just adding this annotation. And I can adjust its behavior by setting just a few properties. So with that being said,
are those properties in YAML?
You can if you want to. You can set it up as a property, a command line arg. It's up to you. YAML is something I use to scare the neighbors back. So I think we're done here, Roy. I mean, that's it, right? We've done it. That's as easy as it gets.
Spring Cloud Task, that's the top of the iceberg, the pinnacle.
There is nothing else better.
Nothing.
Nothing. There's nothing else better. What, you mean there might be something better?
I don't believe Glenn.
You're suspicious, cat? My gosh.
Suspicious cat was rightfully suspicious.
I'm starting to think maybe I might be wrong.
So we've got this other project called Spring Cloud Data Flow. And what do you think it does?
Flows data.
So Glenn's been talking about tasks. It does flow data. I mean, it's self-explanatory, right? I mean, the icon's got zeros and ones.
Oof.
And I think Utsu's going to get upset with me because I'm holding a mic and messing up the audio on this. All right, it's a toolkit for building data integration, real-time streaming, and batch data processing pipelines. And that's a mouthful. What does that mean? Data pipelines consist of Spring Boot apps using Spring Cloud Stream. We haven't talked about streams yet, outside of a few comments earlier on. Spring Cloud Stream is sort of the sister project of Spring Cloud Task for running long-running stream processing. Spring Cloud Task is obviously what Glenn was just talking about for batch processes. And Spring Cloud Data Flow rolls this all up together. So it's ready for data integration with over 60 out-of-the-box streaming and batch apps. So what this means is that we've written a whole lot of stuff for you that you don't have to write for yourself. And we'll show you some of those things in a few minutes.
If you want to write them, you can.
Absolutely. So there's APIs and interfaces for all of the things that you need to be able to do to write those apps. We also provide a DSL and GUI and REST APIs to build and orchestrate data pipelines. Glenn's already talked about Kubernetes and Cloud Foundry. We're going to show some demos again, some more examples of that. And we also have a Spring Cloud Scheduler component, which integrates with these and lets you run the scheduled tasks on these cloud platforms.
So you're saying I can do this? Now?
I think you can. If I remember correctly, you installed a cloud on your computer.
I did? Yeah, I had to literally today. There's a long story about that. You can ask me afterward. There's lots of laughter and a little few tears. All right, let's see here.
Hint, he left it running a long time.
Not configured properly either. This was basically it's running on Minikube. So I scheduled something and then left the schedule on and shut down my Minikube. And when I started back up, I had like 10,000 jobs start up on my Minikube. Minikube wasn't happy. I'm glad it wasn't on.
Nor was your computer.
No, I'm glad it wasn't on GKE. It would have been a lot more fun. All right, here we go. See, he gets me on these asides. He gets me in trouble. So, oh my gosh, look at here. I can do it through Spring Cloud Data Flow. I can actually go in and we can take a look at the apps. These are just some of the, these are literally just some of the apps. I only loaded the ones I needed. But you have all these available tasks. You actually have 60. I only loaded a subset of them because I was lazy. So in this case, we're just going to give you a demo. What does it look like to create a task in Dataflow? So we just saw I should say not to create a task, but we're going to show you how to create a task definition. A few moments ago, we showed you how to actually write your own task. In this case, we just did a system.out print line. Well, in Dataflow, we have just one of our little sample tasks, which just does a timestamp. And we want to create and we just want to create a definition for it. And we can create that task. We give it a name. Let's shrink that back down. And we'll call it my task. So now I have my task, and we can run my task right now as we speak. Launch the task. We can go out and then view that the task is actually running. We can hit refresh. And there we go. We can see actually the task did run. I can select that task, go to executions, and get some information about it. What arguments were passed to it. See, these are things that also task captures for you. It captures this information. Notice that we redacted the information for you so that passwords and stuff wouldn't be revealed. But the other information that is out there is available. We can see that it did, and since it was running on Kubernetes, remember I said an external execution ID? This is the ID that was associated with this given task on Kubernetes. Since it's not a batch job, that's the reason having a little red X there. It just means that it's not a Spring batch job. If it was a Spring batch job, it'd have a little check on it. We could actually dig in and get all the richness of the batch job would offer. And we can see that it ran successfully. While that is cool, I don't think people are going to be waking up at midnight. Their alarm goes off, ring. I'm going to go wake up and I'm going to go hit run. Something about that would be not a good job, good exciting job. So let's go ahead and schedule that right now. We'll go back to my task. We will go in and we will say schedule a task. This is going to look strangely familiar from the examples before, but in this case, we'll just call it my task sched. Task schedule. The cron expression we'll do is, I think it's here already. It's once a minute. Again, like we said, I can pass arguments or parameters onto the schedule. I can say now schedule the task. We now see that we have the schedule here. If you need additional proof, we can actually go down here and see cron jobs, and we see where Dataflow did that for us. Okay, all of it's handled. So now this job is handled and in the scheduler. So a question that Roy has asked me before, stumped me for about 2.3 seconds, but knew the answer, was what happens if Dataflow goes down? The answer is it's already scheduled using Kubernetes Scheduler. It's going to run. It's already primed because Dataflow is just an orchestrator. It sets up the apps, it pushes them out to the cloud, to your cloud instance, where it's Kubernetes or Cloud Foundry, and says, okay, it lets the platform do what the platform does best, which is to run these apps.
So to repeat that, the Dataflow UI simply creates a cron job within the cloud platform, either Kubernetes or Cloud Foundry. And then if Dataflow goes away entirely, the scheduled job is still going to be running, as long as your app hasn't disappeared.
Pretty much. And we can see here was the first task run we ran, which was at 1948, which it was a few minutes ago, but then we can see the one that was scheduled is at 1950. We're at 1951, and then we start to see where they start piling in, right? So we can actually see our tasks. The task that we set up was scheduled. We can actually, again, go into each one if we want to. Show details, and go in and dig in a little bit more if we want to, and be able to, actually that's the Now what we want to do is go into the actual here and be able to view that detail. Okay, and when I'm done with it, which I will do this delete now because I don't want to forget about it and my app just stay running forever, we'll delete that schedule. And we can see the schedule is gone, and we go out again to the magic here, and we see it's all gone. So, with that being said,
data flow is pretty impressive.
Yeah, and it also does streaming too. That's what's really cool.
So are you saying if we have a few minutes left over, you might show us a streaming?
Maybe. So what I'm going to do now is I'm going to send it over to Yes.
All right. We're going to try this again.
But better.
But better. Where's my presentation?
Are you using Clarkson? Are you using Clarkson on your machine? Like leaving the screen as it gets late?
I don't know.
It's kind of yellow.
It's yellow. I'm not doing anything on purpose.
Okay. Resume.
No one goes unless Udo says you can go. Then you go.
All
And we
right.
appreciate him helping out here. What can we see?
Maybe you see me? Oh, that's resolutions are really small, isn't it? Which one do I need? 1080p? Does that look better? YouTube? It's still really yellow, isn't it? Is it night shift? I don't know. Turn off.
There it is. Yay.
Hey.
We just didn't know it.
Apple. Yeah. All right. So where were we? Here, I believe. Okay.
Woohoo.
Thank you for your patience. We will continue now. Data flow installation. What is this? Oops. You want to do that? All right, so where can we install or where can we run data flow? We have Cloud Foundry. We've got projects that help you deploy this onto Cloud Foundry. We have Helm charts and projects that help you deploy and run this onto Kubernetes. All of this stuff is open source. It's freely available. You can go see it, see how all of this was built. Glenn, what is something that the open source doesn't give you?
Well, when it comes time to install, I would say the first thing is that when you install Dataflow, it's actually fairly easy to install. But you have to think about security.
Security is pretty important. Does anybody care about security?
I don't. I'm OSS. We don't care.
In development, we don't care about security because it's really annoying. But then when you go to production, some people care about it. So when we talk about, this is where we talk about the differences between OSS and what we get in the PCF tile. And so PCF is short for Pivotal Cloud Foundry. We have a distribution of Cloud Foundry. Cloud Foundry is open source. Let's see. No, not quite there yet. The team that I work on builds two different tiles. One is called Spring Cloud Services, and one is called Spring Cloud Data Flow for PCF. Both of those are distributed as a package. We call it a tile because, well, it's not on the screen yet. I have a slide that will show you. Because it looks like a square on the installation screen. The tiles are packaged with a lot of security around all of the various components. They make it very easy to install all of these pieces that Glenn just showed you. It's as simple as pushing a button. You have to do very little configuration. The thing that Glenn did not go over very thoroughly
In depth, yeah.
is that there's a lot of dependencies for Spring Call data flow. The version 1.7 has a dependency on MySQL, Redis, Rabbit.
Or a relational database.
Or a relational database,
Yeah.
excuse me.
Redis and also if you're using streams, you have to choose what we call a binder, which is Rabbit or Kafka.
Yep. And within the tile, we do support Redis, and there's options to be able to support Kafka. Again, all of that stuff is made a lot easier within the tile. Let's see. Hi, there we go. This slide covers some of that stuff. The SCDF server on the marketplace is a managed service within Pivotal Cloud Foundry. That means that you can just do a CF marketplace and you can see Dataflow server. You can do a CF create service and create that server. And it'll handle all of the deployment of all of the dependencies and backing services and applications for you. It wires up the OAuth security based on UAA single sign-on. It really handles quite a lot of stuff for you that you may or may not want to deal with yourself. And then here again, we covered this already, but MySQL or relational database for the apps, pipelines, and task history. We've got RabbitMQ for the event messaging, and then Redis for capturing analytics data. And then we also use another component within PCF, which Glenn already showed you, which is Scheduler for PCF. So we make use of that as well. And the security model, which is what we were just talking about, is the UAA security model within Pivotal Cloud Foundry. Allows you to do single sign-on to all of these services. Okay, Spring Call Dataflow tile on the Pivotal network. We've got a website called network.pivotal.io. If you go there, you can search for Spring Call Dataflow or Spring Call Services, which is the other tile. You can download it. This is the installer. Screenshot of the installer. So the current release that's out there is based on the, you can see down here, maybe.
It's 173.
173. I have it on good authority that the 2.0 OSS base tile is currently being tested and will be coming out soon. So, as you know, there's a lag time. We've got OSS has already released a 2.0 version.
Boom, baby.
We have to then take that and then do all of our testing and adjusting for all of the changes that they made in the OSS release. So, talking about tiles, these are the pretty squares that we have. Within Pivotal Cloud Foundry, we've got this screen or this service called Operations Manager. You install these different products within Operations Manager. Under the hood is this component or service called Bosch, and I'm not going to get all into that, but all of these tiles use a technology called a Bosch release that is managed by Operations Manager. And so you upload that tile into Operations Manager and then install it, and this is what you get after you've installed all of these things.
I bet it's hard to install.
So as we just mentioned, the current tile, which is actually 132, is packaged with the OSS v17. Here's a bit of a diagram of the architecture, if you're curious. So we deploy some things into user organ space. We deploy some things into what we call hidden organ space. That's our terminology we use to define this, to deploy the backing services and applications so that they're not accessible from everybody else who uses the platform or might have access to the user's organ space. It's probably hard to see a lot of that, but the idea is that the MySQL, the Rabbit, and the Redis and the data flow server itself, as well as the metrics and skipper apps, which we're also not going to go into much detail, but they're supporting apps that are released to support data flow. Those all get deployed into a organ space that is created on the fly when you provision a new data flow server. And on the user side, what you see is the traditional Cloud Foundry service instance, which is a data flow server. And we also have a few things called proxy services, which proxy to those backing applications and allow the apps that Dataflow deploys to be used within the user space. And that's a whole lot of words, but I'm going to show you an example in a few minutes, which is less than a few minutes right now.
To install that, it's difficult, right?
It is very difficult. So before I do that, this is Pivotal, the Pivotal network, and this is where you can see all the tiles that are available there. We have another website called docs.pivotal.io, and this is where the Spring Cloud Services and Dataflow docs are located for those two tiles. Here's our operations manager. You can see here, we can actually drill into this tile. So this is also the fun part of the presentation where we depend on the internet, and so we'll see how well that works. Okay, so within the tile configuration, you can see that we're defining the services, and these are all defaulted for you, but if you wanted to change the names and things like that, change what services they're being used, you could come in here and change those, and then reinstall the tile, and it would pick up those changes. So Dataflow's got, again, dependencies on those various services. The same thing with Skipper, and the service broker itself has some configuration that it stores in the MySQL database. So if you're not familiar with Cloud Foundry, you set a few of these configuration properties, and then you click this blue button up here in the top right, review pending changes, and wait for it all to install. And it does everything yourself for you. Pivotal Apps Manager. So this is the GUI around the Cloud Foundry, open source Cloud Foundry. So let's see, make this a little bigger. So I've created an org space called demo. I've already provisioned one example of a Dataflow server, but I can show you how we can add another one. You can just,
This is the hard part, right?
it's the hard part.
Okay.
So we have a Dataflow server.
Okay.
We select which plan.
Okay.
And then we come down, and what a name. Oop, we have two, and create.
Wait a minute. That was all?
That's all.
You mean I just did, I had to run 7 Kubernetes scripts and you did it in one click?
That's right.
Show off.
So, yeah, we take a lot of the legwork out of it for you and handle a lot of the deployment so that you don't have to do that. So while that's going, what we can do is I can show you the current one. We've got the same management screen that is also using a self-signed certificate. What? Okay, we're gonna try again.
Stupid internet.
Yeah. All right, applications. Glenn talked about applications. We've got a landing page for Spring Cloud Dataflow, and this is all the open source stuff here. It's more information for you. We have app starters. These app starters are all based on various versions of Boot and Spring Cloud Task. So you can see here, we've got Boot 2.1, Boot 2.0, 1.5. Out of the box, Dataflow does not come with any apps or app starters. So what does that mean, Glenn?
What that means is basically what Roy's going to do is if you look at the way that what he's giving you is actually a list of Maven dependencies. So Spring Cloud Dataflow is going to take in what's called registration. He's going to import all these apps and register these apps. At that time, these apps are still just exactly that. It's just text. So in this case, he imported 3 different apps, which is compose, task runner, timestamp, batch. What he's going to do now is he's going to create a definition for the timestamp. And then what he's going to do is when he creates that definition for that timestamp and he clicks run, at that point, Dataflow is going to pull that app from the Maven repository, or in my case, I was using Docker from the Docker repo. It's going to pull that down and it's going to push that app out to, in this case, Cloud Foundry, but using like a, if you will, behind the scenes, a CF push. But in a Docker, it's just going to be using that Docker image on the Kubernetes.
So I created an app in Dataflow, but I don't see the app yet in Cloud Foundry.
No.
Why is that?
Because you haven't run it yet.
Oh,
remember,
right.
these are just boot apps, right?
So
Dataflow is just doing its job. It's saying, I'm orchestrating.
So I'm manually orchestrating. I started that app.
Yeah, you show off, you.
So now what's happening? Oh, there it is.
Wait a minute, there's an app?
Maybe.
I'm
waiting on it to catch up.
Come on, screen. Come on, Internet. You can do it. Yay, Internet. Woo!
There we go.
Crashed is not bad. Not in this case.
So the status sometimes takes a second to catch up, but you can see on the events over here that it actually started and ran the application.
I have so wanted them to change that name for so long, like not feeling well. So basically what we're waiting on is it's actually pulling the app from the Maven repository and pushing it onto the Cloud Foundry. And looks like we did it.
Now it's run. And you can see that we've got an execution here.
And we see that it's not NANA, which means that it's still running.
We can go and look
or I should say it's starting.
We can go and look at the logs. We can see that there was a timestamp task.
Woohoo!
And there you go.
And now we go back and we should see hit the refresh on the left side. Down, up.
What am I?
There you go. And voila. Same thing as you saw before, but this is running on Cloud Foundry.
So Suspicious Cat really wants to know, is it the exact same cron jobs?
Really? Are we going to go bring Scheduling Cat back in?
Suspicious Cat. Not Scheduling Cat.
Scheduling Cat. Scheduling Cat, Suspicious. We're bringing Suspicious Cat back in.
So for some reason on Cloud Foundry, the scheduler drops the seconds off of the cron expression. So it's one less digit, which is a little...
That was their implementation.
It's a little interesting.
And also notice his is a little different than mine. His has actually got a question mark, so it's feeling more the style of like a Quartz would, where if you look at Kubernetes or /PKS, whichever implementation you're using, it uses kind of the default cron expression.
There we go. So now we have a schedule that's scheduled via the PCF scheduler.
And we'll run once every 5 minutes.
It's going to run once every 5 minutes, just like Glenn said. So what else do we have to offer on the Pivotal Cloud Foundry side?
Good stuff.
Let's take back over here to this slide.
CF CLI. Whoa.
That's right. So we have a CF CLI, and you can create a service. And this is how you would create one that's that uses the scheduler, and so allows you to create and run tasks. You pass it some parameters, and if you like the CLI more than you like the GUI, then this is going to be a much simpler way to do it than clicking the 3 or 4 buttons on the website. But even more than that, what we have are some plugins on the CF CLI. So we have a plugin for Dataflow, and you might say, well, what do we need a plugin for? Glenn did not show you that we have a CLI for Dataflow itself, and it allows you to do all of the interactions that you saw with the website. So there's complementary functionality there. What the plugin does for the PCF CLI is that we have it so secured that it's really difficult to find both the URL and to get the OAuth token for getting to that backing app. We've written a plugin for the CF CLI so that all you have to do is do a CF Dataflow shell and then connect to the deployed application. And I can show you how that works.
You zoom in too close, it's going to be like a 3D movie.
Where'd we go? So this is bypassing all of the trouble that you would have to go through to go find all of those security credentials and the URL, because all of that stuff is sort of randomly generated within Cloud Foundry. Please ignore whatever Java warning is going on
illegal.
And if you're not familiar with the Dataflow shell, this is it. You can do a tab. It's got wonderful tab completion.
Yeah, you can do task execution list and show them what we were showing before, execution list. And remember those two. So look, the second one ran.
The second one is run already.
So in this case, if you remember, we had the UI which showed the task executions. You can do that through the shell here.
What other things are under task?
Destroy.
Task list.
Shows you the definitions that you have. You also can validate the task definition.
Name.
Yeah.
That's my name. My timestamp.
Yeah, that's a valid definition.
Wow.
Woohoo.
So another thing that you can do is you can see the app list here.
So basically, Spring Cloud Dataflow offers a RESTful API in order to do this. You just have two tools. One is the UI, the other is the CLI, which you can actually go in and hit off the RESTful API.
Yep. Quitty.
I'll add that as a command.
So we've got another plugin. It's the Service Instance Logging plugin. What this does, again, the Dataflow server itself is actually deployed into a hidden space. It's protected by the Cloud Foundry security. You don't have access to it typically as the user of deploying a Dataflow application. So we created a plugin that allows you to basically tunnel to that backing application, Dataflow application, and you, stop that a little too quickly. All you have to do, again, CF service logs, and then the name of the Dataflow server, and you can see those logs running. Oh, no. Okay, fun. Well. Oh, no. Ski up. Skip SSL validation running in a development environment with self-signed servers. So there we go. What if I do? So if I'm tailing these logs, what does that mean? I can come back over here to my
Dataflow app, we'll launch it again.
I could create a new task, another timestamp, maybe.
Yeah, you could do that.
And we could call it my
Off to work I go.
My timestamp.
I know my color commentary sucks, but I really try.
So now we got my timestamps 2. And if we go over here and look at the logs, you can see all of that activity going on in the Dataflow server itself. So in this way, your developers, or you as a developer, can monitor the activity of the Dataflow server itself without actually having access to that Dataflow server because it's protected, again, in the backend space. So what else do we have to show, Glenn?
Oh, we're going to go to streams.
We are missing something. What are we missing?
So one thing that we did talk about, and we're going to just use slideware because I know we want to kind of give out some stuff tonight and get y'all home by a decent hour as well. So we talked about tasks, right? Ephemeral apps that go do something, then terminate. But the other thing that you can do is you can also create streams. So one of the questions that you saw earlier is like, why do we have Rabbit? Why do we have Kafka? Why do we even need them for tasks, right? The answer is you don't. But what you can do is you can go in and actually create streams. What this means is that I can create a source, a processor, and a sink, and stream these together. And so let's go back to my original example. So again, we have a major event happening that would bounce DevNexus out of the GWCC called the Magnificent Bowl.
I heard somebody say boring bowl.
Boring bowl, yep. And in this case, so again, let's go back. And so what it is that we're going to be listening to Firehose off of Twitter. So this data is flowing across, and what we're going to do is for that 4-hour event, I'm going to be taking and capture all the tweets that occurred during that time, and I'm going to store that into some kind of HDFS. I may be storing that in some kind of database. And the goal is that after all this is said and done, I'm going to probably go back in and capture trending. What were people talking about beside our product? In this case, we were using Papa John's, right? What are we going to talk about beside Papa John's during this time? So in our example, I said where we could do what's called a tap. I can tap off of that stream and be able to filter that data, and based on that filter, maybe kick off, or in this case, it would be a filter and an aggregator. If the aggregator reaches a certain point, I want it to kick off a task. But that's after that tap. But the main stream is what we really are, we're really capturing all the major data on. I can create other taps off of that and stream that data at different locations. That's what we're talking about streaming, taking live data from a source, processing it at the moment that it occurs, aggregating, filtering, enriching that data. If you've used, how many are using Kafka? How many wish you were not using Kafka? No, Kafka's great. But the thing is about Kafka is you have the ability to go in and create these case streams. You can do, off of a topic, you can go in and Rabbit and do much the same thing, except for in this case it's going to be a queue. So what we're trying to say in this case is I have the ability to create these streams, and then what I can use and what binds these apps together is the Kafka, or is the Rabbit, whichever you choose. And these apps for like the source would be what we call a Twitter source. It's going to be receiving all this data. I'm going to then send it to one or more processors, and these processors may again filter, enrich that data. They may go in and transform that data. And then finally, I'll have a sink or sinks where that data is written out to, where it is that data is stored, or maybe again, like in this case, I may launch other tasks. I may even then go out and do other things with that data in the sink besides store it. But that data is live, so that's the difference between stream and task. Okay. So what Roy's going to do here.
While you were talking,
I saw you.
Copied the URL to the Stream app starters.
You did not.
And I
right in front of these people.
Loaded it in. And so now you get a better idea of all these 60 apps. So I don't know, do you want to...
Do you want me to do it?
Chat about what some of these apps are?
Okay. Well, so in this case, what we're going to do is we're going to just do a quick demo. And we're going to do what's called TikTok. So in this case, what we're going to do is we're going to go to Streams. And we're going to create a stream. And I'm going to say time, pipe, log. In this case, all I'm going to do is, what's going to happen is time's going to emit a message once a second, and it's going to write it out to the log. And in this case, I'm not sure how we're going to get the log data out. Yeah, well, we'll show you that it works.
Just show it works.
Yeah. If I had it on Kubernetes, I could do it. Okay. In this case, it's because we have it on Cloud Foundry, and Cloud Foundry is actually, rightfully so, storing the data or protecting us from looking at the data without permissions, and I don't have access to that. So in this case, what it's going to do is write the message out once a second. So create stream, or use create stream, and then I just say we'll call it TikTok. And we create the stream. Now what's different here is now I've created the stream definition. What I will do now is I can go out and click load, or hit the play button. There we go. And then I can click deploy the stream. Now what it's doing is it's deploying the source, which is time. Thank you. He's about to follow me around with the mic. And in this case, what it's going to do is it's going to deploy a simple app, a boot app. It's called Time, and from that, what it's going to do is going to emit a message to, in this case, to a rabbit queue. And then at the other side is going to be a log sync, and that log sync is going to pick it up, and it's going to write that data out to a log file. And I wasn't prepared to do a demo, so it's...
Well, you can see that it's actually deployed 2 different apps.
Yep.
So we've got a log. And
Yep.
they're both started. Which one do I need to get the logs for?
Log. TikTok. Yep.
The one that says log.
That
Is that
one.
What you're telling
Yeah,
me?
that one.
Yeah, it should be streaming the logs. Oop.
Yeah.
What does that mean?
To NOAA, National Oceanographic Administration.
Is it maybe it's not started yet?
See, that's what happens when we don't plan a demo. Okay, try it now, because now they're saying 1-1. Demo. Oh yeah, you can just go in the logs from here. Haha. See, he's showing off.
See
Where's
the
the
apps?
apps?
Where's apps?
They're there. Woohoo! There you go.
Okay.
Go to log.
Log.
Logs.
There we
Oh,
go.
and there we go. The timestamp's being emitted once a second. But you can actually go out there's a site called Dataflow Samples, and it actually has a discussion on how you can use a free instance, and it's called the Twitter Stream demo. You can look at that and look at the examples of how to do that. It uses what's called Garden Hose, which is free. It does not give you the entire wash of Twitter. It just gives you a subset. I'm not prepared to do a demo on that, but it's always interesting to see what comes from Twitter during a meeting. We've seen some interesting things. But that's pretty much it. Anything else?
Yeah, I think it's really important to review and to reiterate that the functionality for Dataflow is not any different between the OSS version and from what we provide in the PCF tile. Everything is exactly the same. All the UIs and CLIs and everything that you saw there is all available via the OSS. What the tile gives you is ease of installation, ease of setup, and all of the security wrapped around all of the bits and components.
All right. Any questions? Comments? Sleep? Yeah, go ahead.
I think maybe I misheard at the beginning, but you said that if you got something running and it blows up in the middle, you can restart it?
From batch, right. If you implement batch, so it's up to the code to be able to handle that. Batch just has those features out of the box for you. So you can utilize the readers, writers, and processors from batch, and then what you're going to do is set up a context, and then if it fails at any step during that time, when you restart it, it's going to pick up at that step. Yep. There was another question? Yeah. Yeah. Yeah, it probably was. So in that case, what you're going to do is if you already have an enterprise scheduler, what's a typical recommendation I would have is in that case is that they have the ability oftentimes to emit via HTTP a RESTful request. I would have that emit a RESTful request to Dataflow to launch the task. So the guideline is that usually the schedulers are always thinking about on metal. Like, I've got my infrastructure. I'm going to launch it on my infrastructure. But they really don't think about what if my infrastructure is a cloud? How do I go about doing that? And that's where Dataflow can help bridge that. One of the common questions you also get is, and I've seen this happen before, and this is true, I got a Stack Overflow, I think it was a Stack Overflow question or a GitHub issue, and a person says, help. Our scheduler got away from us and launched 60,000 apps on a Cloud Foundry instance. What do I do? I was like, pray. Yeah. So in this case, there's nothing you can do at the time. But when I got that, the first thing we did was we actually created an inhibitor on Dataflow. It's now it says you can have a maximum of 20, 100,000, 10,000 apps that can run at one given time. So we actually have limited that so that you don't overrun data flow, or not data flow, overrun your instance. The other thing that's coming fresh from now 2.0 with data flow is one of the questions we commonly have is it's like, okay, what if I have Cloud Foundry and I have Kubernetes? Can data flow deploy apps to both sides? And the answer is yes, you can. From the same data flow instance, I can create what's called a platform, and I can say, in this case where you saw me do the stream deploy, I hit the deploy button, but if I can have TikTok, I want to deploy TikTok to Cloud Foundry 1. I want to send it to PKS 2. I can actually deploy those streams or launch those tasks on any platform I specify. What's more important in the 2.1 instances is that I can specify, right now it's a global size. I can only launch like 50 apps at a single moment. But in this case, I can actually isolate it and say, for this platform, I won't be able to launch 1,000. My PKS, for instance, may be smaller, only launch up to 100, no more. And Dataflow will honor that. So that's another thing that you get from Dataflow if you utilize that type of framework. Mm-hmm. Yes, sir. Mm-hmm. You have a queue length?
Can you repeat the question?
Okay. So if I have Dataflow, can I establish a queue length on the maximum number of messages that go from one app to the other? Yes, you can. And so the underlying infrastructure between the apps is what's called Spring Cloud Stream. Spring Cloud Stream allows you to configure your app down to that level. We give you, as with like boot, we give you a set of defaults or common sense defaults. But if you need to change that or alter that, you can do that down to that level. But yes, you can. Yes, sir. Mm-hmm. Right. Okay, and you schedule 10,000 messages. So, okay, you want to launch 10,000 jobs. Okay. Yeah. Oh, so maybe launch another job to be able to handle that. So in that case, what you're going to do is you can, that's kind of a loaded question. So what you can do is that I can actually have an aggregator that's placed, or a processor that's placed in the stream. And there's another way to do it too. That's even simpler. And what you can do is if it sees that the message size is getting to a certain size, send a message to the app that will go in and maybe process more, right? Or process those, if you're handling it via stream. Another thing you can do is, one of the questions they have is like, okay, so you're saying I need to inject another app in my stream to be able to do that monitoring? The answer is no, you don't have to. Spring Cloud Stream also allows you to put functions and declare functions that will run prior to your app that are a part of the app. So like, let's say a sync is actually the one that's doing the mailing, and it sees, oh my gosh, I can't handle this load, and the queue's backing up. Maybe I want to take and spawn up another instance of myself. You can have a function that will pick up and maybe spin up another app to do that. But yes, you can. I hate saying yes, you can, but yes, you can. But there's like, it's multiple ways in which you can. We can talk more in detail what your instance is, but yes, you can. Are there other questions? Yes, sir. Like, so from the task side or from the...
So you job runs and fails, you detected that, and you restart. That next restart is failed. Can you have something to say, don't continue to...
So that's Kubernetes default behavior. So Kubernetes default behavior is always to go in and to restart it, infinity. So, and that's just the way that it's set up right now. The task, what it's going to do is record the fact that the app ran and stopped. Typically what people do is they will have a monitor on the task execution table, and it sees that A failed. So the way that I suggest people is what's called self-healing. So the task app runs, and let's say the task app fails. Through Spring Cloud Task, I can actually emit a message to a Spring Cloud Stream application that, in this case, I failed. send a message out to our emailer and email out to somebody, hey, something failed. Can you wake up and see what's going on? The other self-healing thing that it can do is you can have it emit a message out to another agent that may go in, another app that's sitting there, and the app goes in and does some basic diagnostics, and maybe it says, if we do have a failure, try this, try this, try this, and if it does say, hey, in fact, I can fix this, it will go off and relaunch the job. So that's a self-healing that nobody gets woke up, but the other is to have an email that goes out and notifies somebody to wake up. I've seen people also have timers to watch it and watch for failed jobs. So those are 3 things I've heard. But I prefer not to have the timer just because it may or may not catch it fast enough. What you want to do is have the app actually emit messages, and Task allows you to do that. There's it's what's called task eventing. And you can also do it at the batch level. It also allows you to plug into Spring Batch, and at certain levels of batch, it can emit messages on that to a Spring Cloud Stream app. Yes, sir. Huh? Yeah, from Cloud Foundry side, yes. Well, the restart policy for any app or for tasks is never and on failure. That's the only 2 they support. Yes, that's what you would do. Is you'd have that set as never. And like I said, I don't like the on failure because you just will be repeating it. Let me give you an example. So why did I have to kill and remove my entire Minikube earlier today? So Thursday, I was actually putzing with it, working with it, and I brought down data flow because data flow doesn't need it. I just wiped it off. I forgot to remove the scheduled job. Okay. And I stopped my Minikube. This afternoon, before coming in, what does a good presenter do? He brings up his demo, make sure it works so that y'all have a wonderful experience seeing what I have up here. And what I noticed, I had over 10,000 jobs waiting to be run because the scheduler woke up and, he wants to run this job once a minute, and I'm behind. So my Minikube went, by trying to launch all these jobs. So, and the reason is when I had set it up, by default, data flow will allow you to, it sets it to never, but I was actually doing it by hand, and I had it on failure. And it kept doing it over and over. And plus, because the job I was testing with was what? A failed job, one I was actually wanting to fail, and it scheduled like 10,000 of them. So I can tell you that it's called Minikube-delete. And there's an RMF-R to remove all the pods after that. So I'm just glad I didn't have it on my Google account because that would have been even worse. So good question. Thank you. Any others? So now I'm going to embarrass Vincent. You need to come up and, how do I want to give away these vests? So he just gave me the opinion. It's called the Stampede. So what I'm going to do is the following. Volunteers, raise your hands. Come up. So if you volunteered through DevNexus, yeah. Have you volunteered? Have you volunteered before, right? Huh? Another organization? Go for it. Now go pick through. As soon as they're done, so let them pick through. And then what I'm going to let you do is we'll just set them out on the tables. Y'all pick what you want and then take it from there, okay? And in the meantime, is there any other questions or in a Java community that you have or Spring? Yeah, you can write one of your own. Absolutely. So the difference between a source processor and a sync is a source just begins a stream, right? And one of the ones we have is what's called an example here would be a file, right? So a filemon, and basically what it's doing is or it could be a dirmon, which basically waits for a file to get dropped, picked up, process it, and run. In your case, you're probably actually watching the file itself. In that case, what you would do is you would modify the file look at Spring Cloud Stream App Starters. You'll see the file. You can modify that to just watch one file and tail that file. But yes, it can be a source. Absolutely. It's a good question. See, the hard part is that even though we sort of set them in order, yeah. So other questions? Who's ready for Java 12? Gosh, there was excitement, I thought. Java 12.
Did we make scheduling tasks a little bit more interesting? Maybe. I see one head nodding. That's good.
A little.
A little.
Yes, ma'am. Yeah, I'm out. I'm gonna go back up front. I'm walking all over the place. But yeah, go ahead. The difference between AWS and Pivotal Cloud Foundry, it depends on your aspect or your point of view. Amazon has several services that are out there and available that you can use. If you're just using their straight IaaS environment, you can actually deploy a Cloud Foundry onto their IaaS environment. If you're using Kubernetes, they have Kubernetes options out there that you can take advantage of. So AWS is actually offered a wide series of services that are available. Everything from you just put your stuff out there and we'll run it for you to we will provide you the Kubernetes instance for you and go for it. Or you can have your apps and whatnot deployed on their services and you can use on their IaaS services and then you can use their other services. So what AWS has done is created this whole big bevy of services that you can pick and choose from. The advantages are that they're available. The disadvantages are they're costly. As if you're a small, mid-sized company, they're great to start with, but as time goes on, the cost goes up. But that's kind of the good and the bad of it.
So I'm going to turn the question around just a little bit in that Pivotal Cloud Foundry it's not an equality. AWS is the infrastructure that Pivotal Cloud Foundry can run on. Pivotal Cloud Foundry can also run on Google Compute Engine. It can run on Microsoft Azure. It can run on VMware vSphere. So
run on your own machinery.
Yeah, it can run on a variety of different infrastructures, and so you can. Yeah, it's not comparing the same things. Yep.
If there was a triple XL, I didn't know. Yes, sir. Well, PCF is Cloud Foundry is an open source project, and you can deploy it as is. PCF offers features that make the life a lot easier for you, and that's where it kind of comes in and helps out a lot. Well, Red Hat, again, has a bunch of services out there, and OpenShift is their branch off the Kubernetes. But if that's your case, you also want to look at Pivotal PKS, which is more closely aligned with the Kubernetes core and gives you the ability to take care of that. We were talking about security. It uses the security path for you along with other things to help your Kubernetes deployment. So look at PKS as well. I don't want to bite on anybody because I'm the OSS guy, but but that's the differences between the two, which is cool. Okay. All right, guys, I'm giving you about 2 more minutes because I got some hungry people out here. Okay.
Men's, we've got a 5XL, 3XLs, a small.
Okay, they also they run a little small. So are these the ladies right here?
Steve says if you are a woman and you would like a DevNexus vest,
is this ladies here?
I think that's all ladies.
All right. Okay, ladies, here are all the ladies. Come and enjoy. The session's over, folks. We appreciate you coming.